Hello, myself Dimpee Baruah, Assistant Professor from the Department of Mathematics, Majuli College. The topic of the discussion is Introduction to Graph Theory. In this lecture, we will discuss about the fundamentals of graph theory and the uses of graphs to model real-world problems. This lecture is basically for the undergraduate students of mathematics. The contents of the presentation is introduction, basic definitions of graphs, some applications of graph theory, conclusion, and references. Graph theory is a special branch of discrete mathematics which has a number of applications in various areas such as computer science, engineering, social sciences, etc. Graph theory had its beginning in 1736 when Euler considered Königsberg bridge problem, which is stated as: is there a walking route starting at any island that crosses each of the 7 bridges of Königsberg exactly once and return back to the first island? These are the figure of Königsberg. The first figure is the map of the Königsberg and the second figure is the graphical representation of the map. Here the blue dot represents the 4 islands of the Königsberg and the 7 line represents the 7 bridges of the Königsberg. It took 200 years before the first book on the graph theory was written. This was done by König in 1936. Since then, graph theory has developed into an extensive and popular branch of mathematics, which has been applied to many problems in mathematics, computer science, and other scientific and not so scientific areas. Now come to the basic definitions of graph theory. A graph refers to a set of vertices, which is also known as points, nodes, and edges that connects the vertices. A graph is a ordered pair V, E, where V is a non-empty set called vertex set and E is a subset of V cross V called edge set. So in this figure, the vertex set contains the elements V1, V2, V3, V4 and V5, and the edge set consists the elements E1, E2, E3, E4 and E5 and E6. The order of the graph is the number of the vertices of the graph. So for this figure, the number of the graph is 5 and the size of the graph, which is the number of the edges of the graph. So in this graph, the number of edges is 6, so the size of the graph is 6. So in this figure, we see that there may be more than one edge between any two vertices. There may be an edge on a vertex to itself and there may not be any edge incident on a vertex. Depending on this, we have the terms isolated vertex, loop and multiple edges. So isolated vertex is a vertex without an incident edge. A loop is an edge that joins a vertex to itself. And multiple edges are 2 or more edges that joins the same 2 vertices. A graph is called simple if it has no loops and no multiple edges. Otherwise, the graph is called multiple graph. So, for example, in this figure, V5 is an isolated vertex, as there is no edge incident on this vertex. E6 is a loop, as this loop is incident on the vertex V4 to itself. And E2 and E3 are the multiple edges on the vertex V1 and V3. So in this graph, we have isolated vertex, loop and multiple edges. So this graph is a multiple graph. Now directed graph or the graph. A graph is said to be directed if its edge has been associated with an ordered pair of vertices, that is, its edge has a direction. So for it, in this figure, E1 has the direction from V1 to V2. Here V1 is called the initial vertex and V2 is called the terminal vertex. For the edge E2, V3 is the initial vertex and V1 is the terminal vertex, and so on. Now degree of a vertex. So degree of a vertex on a graph is the number of edges incident on it with self-loop counted twice. For example, in this figure, the degree of the vertex V1 is 3 as there is 3 edges incident on V1. Similarly, degree of V2 is 2, degree of V3 is 3 and degree of V4 is 4 as there is 2 edges and 1 self loop which is counted twice. So the degree of the vertex V4 is 4 and degree of the vertex V5 is 0 as there is no edge incident on the vertex V5. Now come to some applications of graph theory. There may be many applications of graph theory. Some of them are as below. In air transportation network, vertices are airports and edges are the air routes of the network. Similarly, in road transportation network, nodes are the intersection points of the roads and edges are the arc that joins the intersection. So in this figure, the dot represents the airports and the line represents the arrow between the airports. This is the figure of airport network of India. Similarly, in protein network, proteins are the vertices and protein-protein interactions are edges. In a molecule, atoms are the vertices and bonds are the edges. For example, this is a graph of carbon dioxide. Here, the atoms are the vertices. Here, oxygen, carbon and oxygen are the vertices and these chemical bonds are the edges for the graph. This is the structure of carbon dioxide. In social relationships, persons are the nodes and friendship are the edges. In GPS or Google Map, the destinations are the vertices and their connections are the edges. Once a problem is modeled as a graph, then we can visualize the problem and by applying theory of graph, we can solve the problems which will be discussed in the next discussion. So conclusion is, this lecture introduces the basic concept of graph theory, also presents some applications of graph theory in everyday life from which we will know about the importance of graph theory in any field. These are the references. Thank you.